Good morning, class. Let us start with the next chapter for today, that is chapter 14, Symmetry. If I talk about this chapter, normally I think you would have heard about this word symmetry. They are symmetrical in nature. Symmetrical basically similar in nature, replica of each other. We call them like that, right? So how do we call? Basically, symmetry means equal, same, shape and size. One important word that comes in our mind is replica. Replica means exact copy. Right? This is what is your ideology related to symmetry. That this is what we have to do. We have to prove that figures are similar in nature, the figures are symmetric in nature. But normally what happens is students do neglect this chapter. They feel this chapter is not important, and even teachers sometimes they don't pay attention much on this chapter. But frankly speaking, this chapter is very important. If you'll see the reasoning part when you appear for your NTNC exams, when you appear for the unknown period, the deciding body who frames the question paper, they are equally emphasizing on the reasoning part. And this chapter is one of the important part of reasoning, where symmetrical, that one particular side is given to you. For example, like I have given like this. What will be the mirror image of this? Like this, to ask the question. All those questions are important. What is the mirror image? What is the water image? So this particular chapter is very important. So do not neglect this chapter. It's very important, though it's completely based on figures. That figures are given, you have to do some sorting and dissorting, and then you have to decide whether the given figure is symmetric or not in nature, right? But do understand the utility of this chapter. This chapter is very important, not for the class 7, not for the class 8, but for future building, because most of the government exams, the 3 reasoning is one of the part, and in reasoning this particular chapter concepts are very important. So let's start with the chapter now. First of all, symmetry. What do you mean by symmetry? If I discuss that, what do you mean by symmetry? Normally I have written that symmetry means, in your ideology, in your mind, symmetry means equal. Symmetry means same shape and size. Symmetry means replica. Exactly, that is the synonyms of this. That's symmetry. Symmetrical in nature. If, for example, if I cut myself, from top to bottom like this, vertically I will be divided into 2 equal halves. Then can I say my body is symmetrical in nature? Again I am repeating. If I cut myself from top to bottom equally, what will happen? My body will be divided into 2 equal halves, and those 2 equal halves are symmetrical to each other. This is what symmetry means. Symmetry basically, when we do any sort of permutation combination, or we do any sort of cutting, division, rotating, flipping, folding, and if we get on folding or flipping or on rotating, if we get the same image back, same shape back, that is what makes it symmetric in nature. Are we clear? So basically, if I talk, what do you mean by symmetry? So symmetry, I'll be writing, if any figure, please understand, if any figure, I'll be writing 3 important words. If any figure is divided, flipped, folded, or rotated. 4 important words are coming to your dictionary. Again, I am repeating this important words. These 4 words are divided, flipped, folded, or rotated. If the same image is received or achieved, the figure is said to be symmetric. The figure is said to be symmetric in nature. Very, very important. Understand again, if any figure is divided, folded, flipped, rotated, and if on doing such thing, if same image is received or achieved, the figure is said to be symmetric in nature. Are we clear about this? This is the main concept about symmetric. Now, these things divided, flipped, folded, rotated, what are these? These are what? The operations which we can do. Operations. That on figure, what can we do with the figure? Either we can cut, or we can fold, or we can flip, or we can rotate. This is what we can do with the figure. So this is what are the operations that we can do on a figure, by which we can mold the figure, we can distort the figure, we can sort the figure. Are we clear? So basically symmetry, if any figure is divided, flipped or folded or rotated, the image, if we receive the same image on doing such operation, then the figure is said to be symmetric in nature. Let me take the example. A brilliant example I'll be taking in front of you. Let me have a rectangle with me. This is ABCD rectangle. Now, if I divide this rectangle vertically with the line, don't you think on cutting I can flip this side on this side or this side on this side, or I may rotate this side on this side or this side on this side. What I am doing is symmetric. I'll be getting same. If I put it like this, this is what symmetry means. Flipping. Understand the meaning of flipping. Flipping. Flip. Fold. Rotating. Rotate. Again. Flip. Fold. Rotating. So basically these three important words, very, very important in this chapter. Very, very important. Flipped, folded, rotated. Because they define the types of symmetry. So basically symmetry, are we clear? If you are able to fold, overlap each other, that is what makes them symmetric in nature. Clear? Now, let's understand, let's talk about the examples from the nature which are symmetric. Now, let me give you the few examples from the nature. Can I take examples from nature which are symmetric? Can I take? Best example, butterfly. Have you seen the wings of butterfly? If you see the butterfly, the wings of the butterfly, they are something like that. They flip like that. Yeah, butterfly looks like that. So their wings are divided in such a formation only. Why? It is symmetric. If they are not symmetric, for example, this wing of a butterfly is heavier as compared to this wing, butterfly will always move in this direction only. To have the balance, to make the balance, that's why they are able to move in the forward direction. Symmetric importance, it maintains the uniformity. It maintains uniformity. Same. It maintains uniformity. It maintains balance. Very, very important. Clear with this? Any doubt anyone is having in this? Secondly, your favorite right now in the pandemic, the most important thing in your life, mobile phones. They are symmetric. You cut mobile phones. They are symmetric. The shape is same. Laptops. Your study tables. Anything else? If you see anything, what else? Apples in nature. They are symmetric. Yes or no? What else? What else we can take? Yes. What else we can take in that form? If you see whole around the nature, you'll be getting symmetric thing. Even Earth, if you cut, you'll be getting proper you'll be getting, because it's a division part. Symmetric, they are symmetric. Even in geometry box, one of the best example. refrigerators. All are the best examples of this symmetry. So there are various things on nature that was symmetric. Flowers, I'll take examples. You might have seen the petals of flowers. They are symmetric in nature. They are all similar in nature. Are we clear with this? So these are the examples from the nature that you can go through. Your homework is this. Try this. See more examples around the nature, from the nature. Okay, clear? Next, let's do the types of symmetry now. So what is the function? What is the main objective of symmetry? It maintains the uniformity plus it maintains the balance. Now let's see the examples. I'll be taking the examples of symmetry. There are two types of symmetry basically in the nature. Line symmetry, the rotational symmetry. I hope you got the word rotated from now. Why I was introducing rotating again and again? Because we have something called rotational symmetry. When we talk about line symmetry, we do talk about two words, that is flipping or folding. Are we clear? Now, when we are talking about line symmetry, it means that to obtain a symmetry, we must require a line. To obtain a symmetry, we must require a line. For example, I gave you an example before. In case of rectangle, what we did? We drew one line to show that yes, rectangle possesses symmetry. What is this line called? This line is line of symmetry only. Line of symmetry, because this line is making this particular figure symmetrical in nature. This is called line of symmetry. Another name of this is axis of symmetry. This is called axis of symmetry. Axis basically means like axis of symmetry. Axis of symmetry. Axis of symmetry. Are we clear with this? So basically, this is axis of symmetry that we are talking about. So basically, a line symmetry needs a line, and that line is known as line of symmetry or axis of symmetry. Now, another name of line symmetry is reflection symmetry. Understand why? It's also known as reflection symmetry. Reflection means mirror. Mirror means image. We see our reflection, we see our image in the mirror. So it means somehow this line of symmetry for sure act as a mirror. Yes, it do act as a mirror. If it act as a mirror, it means that this part is the mirror image of this part, or this part is the mirror image of this part. Hence, it is known as reflection symmetry. Because if the line of symmetry is dividing, these two parts look like mirror image of each other. And mirror image means reflection. Hence, it is also known as reflection symmetry. Are we clear? Are we clear with these two important concepts? Now, when we talk about line symmetry, how do we obtain line symmetry? How do we obtain line symmetry? That is again important. How do we obtain? Normally, how do we obtain line symmetry? There are three methods. By cutting line horizontally. Next, vertically. Next, slantly or diagonally. So either we can cut line horizontally. What do you mean by horizontally? Horizontally means 0 degree. Slipping line, 0 degree. horizontal. 0 degree, horizontal. What do you mean by vertically? Vertically means 90 degree. 90 degree. Horizontally, 90 degree. Horizontally, vertically. Horizontally, vertically. Slant, slant, diagonally. With some angle, diagonally. So let's see the line very importantly that we have to make. Very importantly, for example, this is vertical line. This line is vertical line. Are we clear? This line is vertical. What is this? This is horizontal. Vertical, horizontal. Vertical, horizontal. Can I see an example? If I talk about equator, equator line is horizontal in nature. If I talk about north and south pole, north and south pole, vertical. And in fact, north direction, south direction, west and east, they are again example of west is direction, horizontal, north and south, vertical. Are we clear? This is how we obtain. Either we can cut a line vertically, horizontally, or diagonally. This is how we obtain the line symmetry. Are we clear with the topic line symmetry? How do we obtain? Horizontally 0 degree or 180. 180 means reverse. If I move from A to B, it's 0. If I back move from B to A, it's 180. Reverse direction. So 0 degree or 180 degree, one and the same thing. Clear? Vertical 90 degree. Slant. Clear? Let us discuss the next thing. Now basically we'll see various figures and shapes and how many lines of symmetry they are having. We have to observe that. Very, very important. Very, very important. Shape, number of line symmetry we have to see. First shape that I am going to consider is scale triangle. Scaling triangle. What do you mean by scaling triangle? Whose all three sides are different. All three sides are different. If all three sides are different, means it cannot form any symmetry. Therefore, 0 line of symmetry. Next, isosceles triangle. Isosceles triangle. What do you mean by isosceles triangle? Isosceles triangle means whose two sides are equal. Let us take an example. For example, ABC. It's an isosceles triangle whose side AB is equal to AC. If I draw a line from point A, what happens? It divides this triangle into two equal halves, this part and this part. What is this line called? Though it's a line of symmetry, axis of symmetry, but it has a particular name called median, because median divides a line into two equal halves. That is why it is dividing a line into two equal halves and triangle into two equal halves. Therefore, isosceles triangle have one line of symmetry which is known as median. Are we clear? Next, equilateral triangle. Equilateral triangle. Equilateral triangle. Equilateral triangle, we already know the property that all the three sides are equal and each angle is 60 degree. A, B, C, A, B, C. Each angle is 60 degree, 60 degree, 60 degree. How do we do? Let's see. One line of symmetry, another line of symmetry, another line of symmetry. How many lines of symmetry do you find? 3 lines of symmetry. So 3 lines of symmetries are there in equilateral triangle. Next, rectangle. Rectangle. If I cut vertically, I'll be getting. If I cut horizontally, I'll be getting. Thus, 2 lines of symmetry rectangle has. Clear? Next, let's move on to the next. We'll be talking about now. After rectangle, for sure, we'll be talking about the square. Square, a 4-sided figure whose all 4 sides are equal. Each angle is 90 degree. 90 degree. This is what square means. This is what square means. Let's see the line of symmetry. Vertical, horizontal, diagonal, diagonal. So how many lines of symmetries are there? 4 lines of symmetries are there. 2 diagonally, 1 vertical, 1 horizontal. Are we clear? Next, rhombus. Next, rhombus. Let's see rhombus. What do you mean by rhombus? Rhombus is almost like this. Many of you say it's tilted square. Yes, because though all sides are equal, but none of the angle is 90 degree. Hence, in case of rhombus, and we know that diagonals of a rhombus bisect each other. Do we know that? Diagonals of a rhombus bisect each other at 90 degree. Thus, it will always be symmetric along the diagonals. Thus, 2 line symmetries are there for rhombus. Clear? Next, parallelogram. Next, let's see parallelogram. Why will not consider parallelogram? What happens in parallelogram? Parallelogram opposite sides are parallel to each other, equal. Yeah, it looks. But we can't comment about the angle. If we cannot comment the angle, we cannot determine it with any of the axes. We cannot divide it because angles. If I divide this way, maybe the angles are different. If I divide diagonally, even if the angles are different. Therefore, parallelogram has 0 line of symmetry because we cannot draw any line of symmetry for parallelogram, because diagonally also, because we don't have any conditions for diagonal. We know that diagonals are there for the parallelogram, but what is the condition? That's a different thing. Here, if I talk about the rhombus, diagonal bisect each other at 90 degree. In parallelogram, diagonal bisect each other. At what angle? We don't know. Hence, that's a part that makes too complicated for us. Therefore, 0 lines of symmetries are there. Now, we have a quadrilateral. Let's see a quadrilateral. What do you mean by quadrilateral? A 4-sided figure. Quadrilateral, a 4-sided figure. Let me take any random shape. Because I am talking about quadrilateral, let me take any random shape. It's a quadrilateral, 4-sided figure. Can we go for anything? No, I cannot. If I draw the line of symmetry, I will not get it. So, quadrilateral has 0 line of symmetry. If I take another, again, it's a quadrilateral BCD 4-sided figure, but again not symmetric. That is again a different part. That is why quadrilateral again has 0 line of symmetry. Clear? Now, let's move on to next thing. That is most important. Circle. Now, if I see the shape of a circle, this is called center. Say shape of a circle. This is called center, right? Now, just see. Anyway, if I do, if I pass the line to a center, it is always symmetric. Hence, circle has infinite lines of symmetry. And this line always passes through a center, most important. If you pass a line like this, now you cannot say circle is symmetric because this part is not equal to that part. Hence the line of symmetry always passes through a center. Infinite lines of symmetry. Are we clear with this? Any doubt anyone is having? Clear? Now let's move on to the exercise 14.1 immediately. Immediately we have to move to the exercise 14.1. Question number 1, basically, in question number 1, what they have done, they have given you, copy the figure with the punched hole, exercise 14.1. First question, they are given the figure with the punch hole, for example this hole and this hole is there. We have to draw the axis of symmetry. What is the difference between this axis and this axis? Basically, this means singular and this means plural form, right? So, how will we get symmetry here? One vertical line will make it symmetry. This way we have to draw the line of symmetry for question number 1. You can try it very easy. Question number 2, opposite of this. Now the lines of symmetry are given. We have to draw. I'm doing third part. We have to punch the hole. For example, line of symmetry is like this. Punch is here. Obviously, to have a symmetry, the punch must be here also. Complete like that. Clear? Question number 3. In the following figure, the mirror line means line of symmetry, is given as a dotted line. Complete each figure by performing the reflection. Dotted means mirror line. Reflection we have to. Let's see. This is given to us. Shape is like that. What will be the mirror image? Absolutely. You know that mirror image would be exactly the same. Mirror image. Are we clear? Can we do question number 3? Question number 4. The following figures have more than one line of symmetry. Such figures are said to have multiple lines of symmetry. So, in the figures we have to see the multiple lines. This is the question. Question number 4 is your homework. You have to find which is having only one line of symmetry or multiple lines of symmetry. Right? Question number 5. Let's see question number 5. Basically, question number 5 we will be doing on the graph paper because you will be getting the complete idea. What we have to do in question number 5, we have been given, for example, a graph paper. A graph paper is given to us. 1, 2, 3, 1, 2, and 3. Now, we have to draw one line diagonally. We have to draw one line diagonally and then we have to shape these squares to make it symmetric. Like this. Like this. Like this. Like this. Don't you think it's symmetric? Yes, it's symmetric. Of course, it looks symmetric. This way you have to color the portions. Question number 6. Again, on the graph paper you have to fill. Question number 6 is again the homework. Same, almost same. You have to complete the figure on the graph paper. Question number 7, I have already discussed. You have to line the lines of symmetry for various figures. So this is your homework. Tomorrow we'll be doing and we'll be working on the alphabets, on the letters, alphabet letters, that whether they are symmetric in nature or not, on the basis of line symmetry. So till then, take care and have a wonderful day.